Hello everyone, in this video we're going to do 2016 number 6 at the end of page 19. It's our last free response for chapter 4. And so I love these questions. So they give you a table and they give you different functions. There's f, g, then down here we have k, h. So these are really good questions. And so it says the function f and g are have continuous second derivatives. That just means you can take the second derivative. The table above gives values for each of the different functions and their derivatives, and so then A says let k of x be f of g of x. It's a composite function. So let me go ahead and write this down. So if k of x is f of g of x, and then it says write an equation for the tangent line at x equals 3. And it's tangent to the graph of k. So how do we find a tangent line? Is you use point slope form. And how do you know all your different things is they should give you x1, that's at 3, that was in your problem. y1 should equal the original, so if we're using k, it should equal k of 3. And then the slope should equal k prime of 3, the derivative at that point. So we got to get all these values. We could go ahead and do k of 3 first. So that would be f of g of 3. So g of, you got to work your way from the inside out. So first get g of 3. So you go to your table. And when x is 3, that makes g 6. So g of 3 is 6. And now we want f of 6. So when x is 6, f is 4. So that makes k of 3 equal to 4. Now we'll do the derivative. So we got to go back to our function and take the derivative of this. So we got to get k prime. So how do you do the derivative of a composite function? Something should come to your mind, chain rule. So we have something inside of something else. You can only do the derivative of one at a time. So we're going to do the derivative of the outside, which would be f prime, keep the inside the same, times the derivative of the inside, which would be g prime. Then you could do the times the derivative of x, but that would just be 1. So now we can find k prime of 3. So f prime of g of 3 times g prime of 3. Plug in 3 for all your x's. So g of 3, you go when x is 3, g is 6. So this is going to equal f prime of 6 times g prime of 3. So you go when x is 3, g prime is 2. Now we need f prime of 6. So go when x is 6, f prime is 5. Times 2, so k prime of 3 is 10. So we'll come over here and label that makes our slope 10. So now we just write it in point slope form. So y minus y1 is 4 equals m is 10, x minus x1 is 3. And you can just leave your answer like that or solve it for y if you prefer. Okay, so for part B, let's see what they give you. So they say h of x is g divided by f. Find h prime of 1. So this something should come to mind. If h is g of x over f of x, right? So how are we going to get h? Before you can h prime of 1, you got to get just what is h prime. So h prime, we're going to have to use quotient rule, right? Because we have a function divided by a function. So how do you do quotient rule? Don't think about it in terms of f and g, because when we defined it in your notes, we did f over g. But this is g over f. So the way I word it is I say, you always start with the original bottom, or the original second. So the original bottom is f, times the derivative of the top, g prime, minus, now you switch it, the original top times the derivative of the bottom, f prime, all over, you started with the original bottom here, you put the original bottom here, and you square it. Now we're just going to plug in 1 for all our x's and get h prime of 1. So see if you can do this on your own using the table. So down here it needs to be f of 1 squared. You're not squaring the 1, you're getting f of 1 and then squaring it. So let's see, f of 1. So notice we're going to stay on this row. So f of 1 is negative 6 times g prime of 1 is 8 minus g of 1 is 2 times f prime of 1 is 3 all over f of 1, which is negative 6 in parentheses, being squared. So now we can simplify this. Negative 6 times 8 is negative 48 minus 6 over negative 6 squared would be positive 36. So then we have negative 48 minus 6. So that would be negative 54 over 36. I think I did that right. Okay. So the last thing is evaluate this integral from 1 to 3 of f double prime of 2x. So you've got to be careful on this one. So I'm going to go ahead and write down my problem. Okay, so when you look at this, do not just go too fast. We know that we're going to evaluate a definite integral. You're going to need fundamental theorem of calculus. So we know we need to take the antiderivative, right? But don't go too fast because we have something inside of something else. If that's not just x, if it was just x in here, then yes, you could take the antiderivative f double prime, which means you're going backwards, so it would be f prime. But because you have something inside of something else, we got to use u substitution. So what would you make your u? The inside, which is 2x. So then our du would just be 2 dx. So if you notice, we have, obviously we always have that dx in common, but we don't have an outside 2, so we need to move it over. So we're going to change this to be 1/2 du equals dx. So we're going to go rewrite our equation, or our integral in terms of u. So be careful. You can keep these boundaries, but do not plug them in until you've changed it back to x. So I think that's what most of y'all do. So I'm going to keep them, but just be, technically these boundaries don't go with the u. F double prime 2x is replaced with u, and then dx is what's boxed. It's replaced with 1/2 du. So what do we know? The coefficient is 1/2. You can pull that out to the front. And so we're just left with the integral of f double prime of u du. So now we don't have something inside of something else. It's just one variable in there. So now we can actually take the antiderivative of f double prime. So when you do this, you keep this outside coefficient. I'm going to use a different color since I'm on the antiderivative. Now, what is the antiderivative of f double prime? You're going back one, so it'd be f prime of u. Keep your u. And then we have our boundaries 1 and 3, but remember these are in terms of x, so you cannot plug them in for u. You need to replace your u with what it was holding, so it's 1/2 x prime of 2x. So notice if you forget your u substitution, you're not going to have this 1/2. And now we can do f of b minus f of a. So 1/2 f prime of 2 times 3 is f of b, minus 1/2 f prime of 2 times 1 is f of a. So this would become 1/2 f prime of 6 minus 1/2 f prime of 2. So hopefully we have these on our table. F prime of 6, so when x is 6, f prime is 5. So that would be 1/2 times 5 minus 1/2 times f prime of 2. When x is 2, f prime is negative 2. And this would become 5/2. This is minus, and this becomes a negative, so it becomes plus. I'm going to keep this 2/2 because now I can add these together, and that becomes 7/2. So that is the answer to the last one. That is a good question. So that is all your free responses for chapter 4. I hope this helped, and as always, if y'all need anything, do not hesitate to let me know.